Radar is an object detection system that uses radio waves to determine the range, angle, or velocity of objects. It can be used to detect aircraft, ships, spacecraft, guided missiles, motor vehicles, weather formations, and terrain. A radar transmits radio waves or microwaves that reflect from any object in the path. A receive radar, which is typically the same system as the transmit radar, receives and processes these reflected waves to determine properties of the object. Radar was secretly developed by several nations in the period before and during World War II. The term radar was coined in 1940 by the United States Navy as an acronym for radio detection and ranging. The term radar has since entered English and other languages as a common noun, losing all capitalization. The modern uses of radar are highly diverse, including air and terrestrial traffic control, radar astronomy, air defense systems, anti-missile systems, marine radars to locate landmarks and other ships, aircraft anti-collision systems, ocean surveillance systems, outer space surveillance and rendezvous systems, meteorological precipitation monitoring, altimetry and flight control systems, guided missile target locating systems, and ground-penetrating radar for geological observations. High-tech radar systems are associated with digital signal processing and are capable of extracting useful information from very high noise levels. Other systems similar to radar make use of other parts of the electromagnetic spectrum. One example is LIDAR, which uses ultraviolet, visible, or near-infrared light from lasers rather than radio waves. History. As early as 1886, German physicist Heinrich Hertz showed that radio waves could be reflected from solid objects. In 1895, Alexander Popov, a physics instructor at the Imperial Russian Navy School in Kronstadt, developed an apparatus using a coherer tube for detecting distant lightning strikes. The next year, he added a spark gap transmitter. In 1897, while testing this equipment for communicating between two ships in the Baltic Sea, he took note of an interference beat caused by the passage of a third vessel. In his report, Popov wrote that this phenomenon might be used for detecting objects, but he did nothing more with this observation. The German inventor Christian Holzmeier was the first to use radio waves to detect the presence of distant metallic objects. In 1904 he demonstrated the feasibility of detecting a ship in dense fog, but not its distance from the transmitter. He obtained a patent for his detection device in April 1904 and later a patent for a related amendment for estimating the distance to the ship. He also got a British patent on September 23, 1904 for a full radar system, that he called a telemobiloscope. It operated on a 50 cm wavelength and the pulsed radar signal was created via a spark gap. His system already used the classic antenna setup of horn antenna with parabolic reflector and was presented to German military officials in practical tests in Cologne and Rotterdam Harbour but was rejected. In 1922 A. Hoyt Taylor and Leo C. Young, researchers working with the U.S. Navy, had a transmitter and a receiver on opposite sides of the Potomac River and discovered that a ship passing through the beam path caused the received signal to fade in and out. Taylor submitted a report, suggesting that this might be used to detect the presence of ships in low visibility, but the Navy did not immediately continue the work. 8 years later, Lawrence A. Hyland at the Naval Research Laboratory observed similar fading effects from a passing aircraft. This led to a patent application as well as a proposal for serious work at the NRL on radio echo signals from moving targets. During the 1920s, the UK research establishment made many advances using radio techniques, including the probing of the ionosphere and the detection of lightning at long distances. Robert Watson Watt became an expert on the use of radio direction finding as part of his lightning experiments. As part of ongoing experiments, he asked the new boy, Arnold Frederick Wilkins, to find a receiver suitable for use with shortwave transmissions. Wilkins made an extensive study of available units before selecting a model from the General Post Office. Its instruction manual noted that there was fading when aircraft flew by. Before the Second World War, researchers in France, Germany, Italy, Japan, the Netherlands, the Soviet Union, the United Kingdom, and the United States, independently and in great secrecy, developed technologies that led to the modern version of radar. Australia, Canada, New Zealand, and South Africa followed pre-war. Great Britain and Hungary had similar developments during the war. In France in 1934, following systematic studies on the magnetron, the research branch of the Compagnie Générale de Télégraphie Sans Fil, headed by Maurice Pont, with Henry Gutton, Sylvain Berliner, and M. Hugon, began developing an obstacle locating radio apparatus, a part of which was installed on the Normandy liner in 1935. During the same time, the Soviet military engineer P.K. Oshchepkov, in collaboration with Leningrad Electrophysical Institute, produced an experimental apparatus, Rapid, capable of detecting an aircraft within 3 kilometers of a receiver. The Soviets produced their first mass-production radars Rus-1 and Rus-2 Redut in 1939, but further development was slowed by the NKVD arrest of Oshchepkov and their sending him to the Gulag. In total, only 607 Redut stations were produced during the war. The first Russian airborne radar, Nis-2, entered into service in June 1943 on P-2 fighters. More than 230 Nis-2 stations were produced by the end of 1944. The French and Soviet systems, however, had continuous wave operation and could not give the full performance that was ultimately at the center of modern radar. Full radar evolved as a pulsed system, and the first such elementary apparatus was demonstrated in December 1934 by the American Robert M. Page, working at the Naval Research Laboratory. The following year, the United States Army successfully tested a primitive surface-to-surface radar to aim coastal battery searchlights at night. This was followed by a pulse system demonstrated in May 1935 by Rudolf Kuhnhold and the firm Gemma in Germany, and then one in June 1935 by an Air Ministry team led by Robert A. Watson Watt in Great Britain. Development of radar greatly expanded on 1 September 1936 when Watson Watt became superintendent of a new establishment under the British Air Ministry. Bawdsey Research Station, located in Bawdsey Manor, near Felixstowe, Suffolk. Work there resulted in the design and installation of aircraft detection and tracking stations called Chain Home along the east and south coasts of England in time for the outbreak of World War II in 1939. This system provided the vital advance information that helped the Royal Air Force win the Battle of Britain. In 1935, Watt was asked to pass judgment on recent reports of a German radio-based death ray and turned the request over to Wilkins. Wilkins returned a set of calculations demonstrating the system was basically impossible. When Watt then asked what might they do, Wilkins recalled the earlier report about aircraft causing radio interference. This led to the Daventry Experiment of February 26, 1935, using a powerful BBC shortwave transmitter as the source and the GPO receiver set up in a field while a bomber flew around the site. When returns were clearly seen, funds were immediately provided for development of an operational system. Watt's team patented the device in GB 593017. Given all required funding and development support, the team had working radar systems in 1935, and began deployment. By 1936, the first 5 chain home systems were operational, and by 1940 stretched across the entire UK including Northern Ireland. Even by standards of the era, CH was crude. Instead of broadcasting and receiving from an aimed antenna, CH broadcast a signal floodlighting the entire area in front of it, and then used one of its own radio direction finders to determine the direction of the returned echoes. This meant that CH transmitters had to be much more powerful and have better antennas than competing systems, but allowed its rapid introduction using existing technologies. In April 1940, Popular Science showed an example of a radar unit using the Watson-Watt patent in an article on air defense. Also, in late 1941, Popular Mechanics had an article in which a U.S. scientist speculated about the British early warning system on the English East Coast and came close to what it was and how it worked. Alfred Lee Loomis organized the Radiation Laboratory at Cambridge, Massachusetts, which developed the technology in the years 1941 to 45. Later, in 1943, Page greatly improved radar with the monopulse technique that was used for many years in most radar applications. The war precipitated research to find better resolution, more portability, and more features for radar, including complementary navigation systems like OBO used by the RAF's Pathfinder applications. The information provided by radar includes the bearing and range of the object from the radar scanner. It is thus used in many different fields where the need for such positioning is crucial. The first use of radar was for military purposes, to locate air, ground and sea targets. This evolved in the civilian field into applications for aircraft, ships, and roads. In aviation, aircraft are equipped with radar devices that warn of aircraft or other obstacles in or approaching their path, display weather information, and give accurate altitude readings. The first commercial device fitted to aircraft was a 1938 Bell Lab unit on some United Airlines aircraft. Such aircraft can land in fog at airports equipped with radar-assisted ground-controlled approach systems in which the plane's flight is observed on radar screens while operators radio landing directions to the pilot. Marine radars are used to measure the bearing and distance of ships to prevent collision with other ships, to navigate, and to fix their position at sea when within range of shore or other fixed references such as islands, buoys, and lightships. In port or in harbor, vessel traffic service radar systems are used to monitor and regulate ship movements in busy waters. Meteorologists use radar to monitor precipitation and wind. It has become the primary tool for short-term weather forecasting and watching for severe weather such as thunderstorms, tornadoes, winter storms, precipitation types, etc. Geologists use specialized ground-penetrating radars to map the composition of Earth's crust. Police forces use radar guns to monitor vehicle speeds on the roads.